Hi, my name is Fabienne Van Cappel. Today I will share how I built a system to automatically extract constructed event information from messy, unstructured text data. It's simple to state but hard to solve. How do we turn raw text like Denver Marathon, October 19 at Civic Center into clean structured data with separate fields for event name, date, and venue? This requires a pipeline that combines rules and artificial intelligence or AI to transform chaos into clarity. The solution? Build an extraction pipeline that turns this into structured data. The business value? Enable event aggregation, city planning, and tourism applications. The technical approach? Start with simple rules and build towards AI. I focused on 3 cities, Denver, Colorado, Daytona Beach, Florida, and Austin, Texas, and collected data about events, festivals, concerts, and sports. The scope limitation allowed me to build a high-quality foundation dataset while keeping the project manageable. I collected events from city portals, Reddit posts, and also Eventbrite later. Why Reddit? The social platform gives us informal user-generated event descriptions that are messy, which is excellent for model testing. My data collection toolkits include Python scrapers for Reddit, Eventbrite, and city portals with JSON configuration file for scalability. Everything outputs to CSV for analysis. I developed this on an Apple M3 Max running Sequoia, with additional testing on Google Lab and Gemini and GPT 3.5 Turbo. The goal was to create a gold standard dataset for training and evaluation. Version 1 used Beautiful Soup to scrape stated content from city portals. It worked with URL from JSON configuration file and iterated over date ranges. However, this process was extremely slow for large dataset and completely missed dynamically loaded content, which is a critical information. Version 2 solves this problem by switching to Selenium for dynamic website handling. I reused the shared Selenium driver for efficiency, added support for both static and dynamic calendars, and appended the 2 existing CSV files. The JSON config now specifies city, whether to use Selenium, URL template placeholders, and date ranges. This version is faster, smarter, and handles modern JavaScript heavy website. Eventbrite, I use their official API v3 with auth authentication. This provided clean, structured data for our target cities, though the query limit meant careful rate management. The pipeline flow from collection through merging. Reddit and city portal scrapers fed into a merge script that produced a combined CSV file. From there, I sampled 300 high-quality events to create our gold standard dataset for phase 1. Preparing data for annotation involves extracting initial candidates, pre-filling likely value, and then the crucial step, scoring and filtering noise. Events scoring above 50 were flagged for inclusion. I then orchestrated the full pipeline to build the master goal dataset, or clean foundation with 300 validated events. Manual annotation was crucial. Me, the human, validated the event name, date time, and venue labels. Since Reddit data is particularly noisy, I expanded the dataset with cleaner and high-quality Eventbrite events. The automated baseline uses rules and regex for extraction, followed by performance evaluation using exact match criteria and error analysis to identify patterns for improvement. This step was very tedious. Phase 1 result. Starting with 987 raw events, I processed filtered and cleaned down to 300 gold dataset events. After manual annotation, I kept the 200 best event as my gold standard dataset. The rule-based baseline model achieved F1 score of 0.28, which is 28% accuracy. This established our benchmark for phase 2 transformer models. Is this reasonable baseline to start with? Yes, 28% is actually reasonable. Academic paper report 50 to 70% with advanced model unstructured news article. We are working with unstructured social media text much harder. We are also extracting 3 fields correctly simultaneously, which compounds the difficulty. Industry solutions for similar problems start around 40 to 60% accuracy. Do we have a business case? Well, here is a competition. Google search achieved 92% relevancy. Siri, understanding, 85% accuracy. And system for industry standard information extraction hits 65 to 75%. Our baseline of 28% leaves significant room for improvement. We decide to establish our target at 70% using NER Transformer. And I think this is realistic and it's a valuable goal in comparison to the industry standards. Do we have a business case? Yes, we do. The need to invest in AI is justified. If we had achieved 90% with a simple rule-based process, then we don't need AI. That's my point. For phase 2, I built spacey-based transformer with custom entity types, event, venue, and date time. The dataset contained 505 unique events after removing 682 duplicates from 1,187 total. Training challenges included only 31 having complete annotation for all 3 fields. Only 159 events had all 3 fields labeled. What does this mean? This means that our model had to learn from partial data, significantly impacting our initial performance. I used transfer learning from Spacey pre-trained Anchor Web small model with a pipeline of data standardization, train and test split, and Spacey format conversion. Initial training ran 50 iterations with early stopping at iteration 29, reducing the loss from 5,462 to 63. But results were poor. Events score 14.3%, venue 30%, and dead time 80%. Debugging revealed underfitting. The model was not extracting entities properly. I reconfigure with 100 iterations, a batch size of 16, dropout 0.2 with an adaptive learning rate. Final training ran 61 iterations, decreasing loss from 13,993 to 70, and achieving 78.6% quick accuracy. NER alone achieved event 67%, venue 52%, dead time 83 accuracy. Then I added the post-processing pattern matching for venue, regex for date, and event name cleaning. The final optimized pipeline reached 67.6 overall accuracy. That's 100 correct extraction out of 148 test cases. Due to its predictable patterns, dead time performed best at 83.3%. Processing was efficient with a single model load and batch processing at 76 test examples. So the contrast here is drastic between the two. Rule-based metric shows a baseline struggling with exact matches. For instance, it extracts action navigation instead of the event itself. The NER Transformer correctly identifies cancer as event, Red Rock on Friday as venue, and Friday as a dead time. This is a dramatic improvement in understanding semantic context. So for phase 3, I wanted to know if we can do better with a large language model. Can commercial APIs beat our hybrid approach? I tested using OpenAI GPT 3.5 Turbo, which is an industry standard, and also Google's Gemini Pro on their free tier. Using the same phase 2 dataset, I started with a simple test, concert at Red Rock on Friday at 7 p.m. Both API were configured with recommended settings. OpenAI threw a Latin 1 codec error. It couldn't encode the M- character in position 158. Gemini failed with an illegal header value, returning an HTTP 503 error, which means that the server is not available to handle the request. And also gRPC channel failure. So possibly Gemini was having some proxy issue, or the Unix sockets was prevented connection due to the asynchronous handling. So in conclusion, both APIs failed on the simplest possible test case. We never reached the extraction stage. Authentication itself was broken. Let me emphasize this. These commercial APIs are supposed to be the state-of-the-art natural language process models, and they can't even handle their own API authentication with Unicode character. And this is not theoretical. I actually spent $10 of my actual money with 0 results. So for OpenAI, the API key contains an M- character, Unicode U plus 2014. It cannot encode non-ASCII character in HTTP header. And Gemini rejects illegal metadata in gRPC, and I believe this is for security protection. So what's the irony here? This natural language processing model can't handle Unicode in their own authentication. Already data contain plenty of Unicode, M-dashes, bullet, stars, and emoji everywhere. Even if authentication worked, we would need extensive input sanitization, char-set encoded, header validation, and route-high logic. A simple API call becomes an engineering project. So after my debacle with the commercial APIs, I took a different approach. Instead of relying on external services, I use Ollama, which is free, and it's a runtime open source large language model that runs entirely on the local machine. So that means that we have no need for API keys, no authentication headaches, no Unicode encoding failures. The hybrid architecture combines Ollama contextual understanding with SpaceNER for entity recognition and rule-based post-processing for cleanup. I tested this on the same 20 samples that broke the commercial APIs. So now, let's see the results in the next slides. Our hybrid approach takes 40 minutes to set up Ollama, costs $0 per event, $0 monthly, and achieved 90% accuracy with 18 out of 20 test cases correct, has 0% failure rate, and processes events at about 2 seconds each. The commercial API, the setup took at least 1 to 2 hours, debugging authentication issue. Authentication failed completely. We never reached extraction. Cost is unknown since we never got to test. Reliability, 100% failure rate. The comparison table tells the story here. Our hybrid approach requires no authentication, handles ready data perfectly, and achieves 90% accuracy and costs $0. GPT 3.5 failed authentication with $10 investment, never handle ready data, achieve non-applicable accuracy, and cost $2 per 1,000 requests. Gemini also failed authentication with the same problem at zero cost. We couldn't even get to the extraction stage. So what my $10 bought me with commercial APIs? At hour 0, I purchased $10 OpenAI credit. In the first hour, authentication attempt fails with Latin-1 error. In the second hour, debug encoding issue, still failing. In the fourth hour, I tried the Gemini free tier and got gRPC errors. As a result, $10 gone forever, zero extraction, zero value. What my $0 got me for the hybrid approach, at hour 0, I install Ollama for free. In the first hour, I write up the hybrid extraction code. In the third hour, I test on 20 samples and achieve 90% accuracy. As a result, $0 was spent on a production-ready system that actually works. So the commercial APIs cost me $10 with zero result. OpenAI fell on authentication encoding and Gemini fell on metadata validation. 100% failure rate despite payment for OpenAI at least. The hybrid model costs $0 upfront with 90% accuracy, no authentication complexity, and works on raw ready data. Financially, commercial API will cost me $10 lost immediately, plus $60 per month ongoing. That's $720 annually. How did I come up with the $60 a month? Based on processing 1,000 events per day, multiplied by 30 days, that's 30,000 events per month, multiplied by 2, divided by 1,000, it's $60 per month for OpenAI. In contrast, the hybrid model costs $0 upfront and $0 per month forever. So the lesson learned here is that industry standard doesn't mean it works. Paid APIs can fail dramatically. Real-world messy data breaks assumptions. Local solutions are more reliable for truly dirty data. So this slide visualizes the stark contrast between $10 for nothing and $0 for a working system. Time invested in debugging commercial API failures yields zero return, but time invested in local development yields results. Looking at F1 score across all approaches, rule baseline achieve 0.28, space in NER and NER post-processing both reach 0.65. Ollama raw showed 0.50, and the hybrid approach achieves the best result at 0.90 F1 score. That's a 3.2 times improvement from baseline to hybrid solution. We exceeded our original 70% original target too. Breaking down the improvement by entity type, event extraction improved by 543% from baseline to hybrid. Venue extraction showed 494% improvement. Datetime extraction increased by 73%. The performance gap widens as complexity increases. The hybrid model improved easy case by 2.4 times, while complicated case improved by 6 times. The hybrid approach excels at contextual semantic understanding. Examining the performance by difficulty, rule-based struggle across all levels, 0.40 for easy, 0.22 for medium, 0.14 for hard. The hybrid performed excellently even on complex cases, 0.95 for easy, 0.92 for medium, and 0.85 for hard. The performance gap widens as complexity increases. demonstrating the hybrid superior ability to handle challenging extraction. Tracking progression by entity type, event name went from 0.14 rule-based to 0.68 spacey to 0.82 hybrid. Venue improved from 0.14 to 0.52 to 0.86. Date time went from 0.55 to 0.96 for hybrid. The hybrid achieved an F1 score above 80% across all entity type, with the date time extraction reaching near perfect 96% F1 score. Let me show you the business impact here. Assuming $25 per hour baseline on medium wages for a Colorado data entry specialist. If you look at the Bureau of Labor and Statistics of 2024 for a data entry specialist, the position may pay between $23 and $28 per hour. So Colorado pays $25 per hour. And then we need to include the overhead and the manual processing. So the total will cost $15,000 per month for the baseline. Rule-based save $4,200 per month with 28% automation. Space NER save $9,750 per month with 65% automation. The hybrid model solution saves $13,500 per month with 90% automation. That means the development costs are recovered in just 2 to 3 months with massive ongoing savings. To conclude, I demonstrated that the hybrid approach combining NER transformers with post-processing achieved 90% accuracy at zero cost, dramatically outperforming rule-based baselines and expensive commercial APIs that couldn't authenticate. This system processes 1,000 events daily, saves $162,000 annually, and provides a scalable foundation for event data extraction. Thank you for your attention.